What's up, team? Let's talk about the geometric mean. We have a situation similar to what we talked about in the last lesson, the right triangle altitude theorem. So if this doesn't look familiar, if you don't know why I have three triangles right here, please go back and check out that video. I'm not going to recap it all here. Okay, so here we go. We have this triangle JOS. OH forms the altitude here. There's a right angle. And what I've done is I use lowercase letters to denote lengths. I kept them general, so I put letters in there instead of making up numbers. So to show you that this always works versus just in a specific case. So the uppercase JOSH, those are the vertices. The lowercase A, B, C, D, and E, those are all representative of lengths. We don't actually know what those values are, but I gave them values so that we can work with them. Okay, I've separated this out into three separate triangles. We know they're all similar. Again, based on the last video, right triangle altitude theorem. Check it out if this isn't making sense yet. One thing I want to point out, I want to ignore this big one. I'm not even going to use it. I'm going to focus in on the medium and on the small ones. And I'm going to create a ratio so we can do a little bit of algebra so we can try to unpack some unique patterns here. I'm noticing that B and C in this case, so SH and OH, those are corresponding sides. So the ratio of B over C is going to be the exact same ratio as HO over HJ, which is length C over length A. Oops, I should keep that lowercase to be consistent. And again, I populated this whole thing from up here. So this CHO it happens to be the short leg here, but it happens to be the long leg here, and that's just from the picture. I didn't move anything around. I didn't actually do any math to go from here to here. I just copied it. Okay, so if this ratio is true, and we do a little bit of cross multiplication, meaning we're going to do C times C to get C squared, and then B times A to get BA. Let's say we wanted to solve for C. I would take the square root of the left side and the square root of the right side. This equation right here, C equals the square root of B times A, we call the geometric mean. The geometric mean. So it's kind of like when you're finding the mean of a set of numbers, you add them all together, divide by that number of numbers. This is similar-ish to that, but we call it the geometric mean. And basically what's going on, if you notice, this length C is the altitude. So if you're trying to find the length of that altitude, all you would need to do is multiply the lengths of A and B, which are here, and then find the square root of whatever that product is. So let's do an example of that. I have two examples, and then we'll wrap this up. This one won't take too long. So here we're trying to find out what the altitude is. In this case, we call it X instead of C. And we know by following this formula, we just need to multiply the A and the B lengths. In our case, it's 5 and 11. Multiply them together, find the square root. So it's going to look like this. X equals the square root of 5 times 11. And if that feels too easy, it should. It is a pretty sweet shortcut here. So X equals the square root of 55. I don't know what the square root of 55 is exactly, so let's grab a decimal approximation here. And so it looks like X is approximately 7.42. That's the length of the altitude. Sweet. Let's do one more example here. In this case, we actually have the altitude. It has a length of 10, and we have one of the short legs, but we're missing this this long length here. So we're going to set it up so similar. Instead of X being on the left-hand side, we actually know what the altitude is. So it's going to be 10 times the square root of 5 times X. And it's probably a little uncomfortable having an X under the radical, but we can live with that. So we're going to square the right-hand side, square the left-hand side. When you square the left-hand side, 10 times 10 is 100. When you square the right-hand side, well, really just the radical goes away. That's cool. So now we have 100 equals 5x. Divide both sides by 5, and we learn that x equals 20. So this length right here is 20, whereas this one is approximately 7.42. So a couple of different ways to use the geometric mean. Generally, you're going to see it this way, searching for the altitude. But sometimes it's going to be a little bit trickier where you have the altitude and you're missing one of the other pieces. Just use the same formula here. C equals the square root of B times A, and plug in the pieces you actually have and seek the unknown ones. Okay, that's geometric mean. Let's dive into some practice problems. Let me know if you have questions. You got this.